At whatever time of the day you are watching this video, good day guys. So what we're going to look at in this lesson is simply the relationship between the number of moles of a substance and the molar mass of that substance. So we're going to denote the molar mass by mm, whereby the first letter is a capital letter M, and you probably know by now that the number of moles are denoted by a small letter n. Now let us define the molar mass and perhaps explain what the definition mean. So now the molar mass of a substance is simply defined as the mass of 1 mole of that substance. Now what does that mean? So it simply means that we have molecules that make up 1 mole of that substance, a number of molecules that make up 1 mole of that substance, or a number of atoms that make up 1 mole of that substance. So when you simply take that mole of that substance and put it on a scale, so whatever mass we measure, it's going to be the molar mass, because we're measuring the mass of 1 mole of that substance. Now, how do we find the molar mass? So the molar mass will simply be the algebraic sum of the relative atomic masses of each atom that makes up the substance. So what does the red line mean? It simply means we're going to look at the substance closely to what makes it. So now if there are 5 atoms in that substance, we are going to find the relative atomic masses of each and every atom that is present and just simply add it together. So the algebraic sum of those relative atomic masses will be the molar mass of that substance. At times you find that a substance is made up of an element, so the atomic mass of that element will therefore become the molar mass. Now, a molar mass have the SI units grams per mole. That is how you pronounce this abbreviation. You say grams per mole. So we understand by now that per is simply a mathematical idea of a division. So now when we say per, that means we're going to have a -1 here, and we understand that a -1 is simply giving us a fraction, because we can take the mole to a denominator. So there is some division that is happening here. I will explain later. I will come back to this SI units later on. Now let us find the molar mass of hydrogen. I did say that for each substance we're going to look at the atomic mass that makes up that substance. So we have an element as a substance in this case. So what is the atomic mass of this substance? From the periodic table we know that it's going to be a 1 gram per mole. And then we also find the molar mass of oxygen. The molar mass of oxygen will simply be, what have I done here? So the molar mass of oxygen will simply be a 16 grams per mole. And then let us try to interpret what these molar masses are giving us. So now this simply means that 1 mole of hydrogen, will weigh 1 gram. Okay, 1 mole of hydrogen will weigh 1 gram. And again, this means that 1 mole of oxygen will weigh how many grams? 16 grams. That is why it's called a molar mass, because it's a mass of 1 mole. Okay, so this is a mass of 1 mole. There is a mass of 1 mole, as we can see. Now let's find a molar mass of water. So how many atoms make up water? There are 3 atoms, because we have 2 hydrogens and 1 oxygen. So how are we going to find this molar mass? We're simply going to add all the relative atomic masses of each and every atom that is found in this compound. So we know that each hydrogen is a 1 gram per mole. So I'm going to say 1 for the first hydrogen, plus another 1 for the second hydrogen, and then I add 16, because that is the mass of 1 mole of oxygen. So now you find the algebraic sum. One person understands their maths, so they will say, I have 2 atoms of hydrogen, but 1 hydrogen weigh 1 gram per mole. So they add the 16. So these calculations should ideally give you the same answer, being 18 grams per mole. So what does this molar mass indicate? So the molar mass of water tells us that 1 mole of water 1 mole of water will weigh 18 grams. 1 mole of water will weigh 18 grams. Now, I think from looking at the whole thing that is happening here, we can come to a conclusion that there is a relationship between a molar mass, the mass of a substance, and the number of moles. Even these calculations are suggesting the same thing. The molar mass of a substance is related to the mass of a substance and its number of moles. Now, we do have a mathematical relationship that indicates what I'm saying. This is the mathematical relationship we're going to look at that kind of relates the number of moles of a substance to its mass and its molar mass. So we're going to use this formula to find the number of moles of a substance when we are given the mass, or to find the mass when we are given the number of moles. And then we know how to find the molar mass at this stage. Now, example, calculate the number of moles in a 196 grams sample of sulfuric acid. So we are given the chemical formula of sulfuric acid. So I'm just going to put this on a side as we do this calculation. So the first thing, as you can see in this formula, we have molar mass. That means we've got to find the molar mass because it's just a simple calculation. We're going to find the relative atomic masses of each and every atom that is present. So how are we going to do this one? So we know that we consider each and every atom. So here we have 2 atoms of hydrogen, but each hydrogen weighs 1 mole, weighs 1 gram per mole, and then we add the molar mass of sulfur, which is 32 grams per mole. And then lastly, we can see that we have 4 atoms of hydrogen, but each hydrogen weighs 16 grams per mole. So now this gives us a total answer of 98 grams per mole. Okay, that is the total molar mass of sulfuric acid. Now, what is the first option we're going to use to find the number of moles? So now we can interpret this molar mass. So what does this molar mass mean? This molar mass tells us that 1 mole of H2SO4 will weigh 98 grams. So now, what are we given in this question? We are given the mass now. They want us to find the number of moles. So I'm going to write the mass under the mass. So we are now given 196 grams, and we are required to find the corresponding number of moles of sulfuric acid. So what do we do from here? We're going to cross multiply and then divide. So now this is going to give us a 98 multiplied by the number of moles of sulfuric acid, and this should be equivalent to 196. So if we divide on both sides by 98, the number of moles of sulfuric acid will therefore be 2 after dividing by 98 on both sides. This is option number 1. You are allowed to use this. So I've used the molar mass as a conversion factor between the number of moles and the mass. The first step will be, of course, to find the molar mass, because we're going to use that molar mass as a conversion factor. Another person can just simply use that formula. So the formula says, to find the number of moles of a substance, you're going to say the mass over the molar mass. The SI units are written for you. The mass should always be in grams to be used in this formula. So what do we do here? The number of moles of sulfuric acid is equal to, I'm not going to write the formula, but the mass is 196, and then we divide by 98. We can see that we're getting the same answer here as above. So what do we get here? We get 2 moles. Okay, and that is the end of this lesson. I hope you enjoyed.